Good morning, everybody. We'll get started in about 3 minutes or so. Thanks for your patience. We'll get started in a couple minutes. Thanks for your patience. All right, everybody. Thanks for joining in this morning. Just a reminder that this class session is being recorded. I will share the recording in the announcements once we're done and I get the video caption. So might check the announcements by tomorrow and I'll post the video for this class. All right, so let me go ahead and share my screen. Will somebody kindly unmute and let me know if you're seeing the class homepage?
We see it.
Thank you very much. Okay, so just to quickly recap, last week we dealt with the nature of science, and we looked at the scientific method, we looked at the experimental process, we looked at the connection between science and technology. And then on Thursday, we focused in more closely on the metric system, in particular, the base units and base properties. We looked at the metric prefixes and their associated powers of 10. And then we ended last week by looking at derived properties like volume and their associated units, and then density and its associated units. And then we looked at some sample problems that utilize the property density And I showed my problem solving pyramid, which allows you to bypass solving an equation for density and just looking at how you can use that pyramid to find any variable that you're looking for, either through multiplication or division. So those were the things that we covered on last week. So before we move forward, I'd like to open up the floor and see if there are any questions that I might answer, and then we can move forward with this week's material dealing with units and unit conversion. Okay, so I'll take that silence to mean that I've addressed any questions that you might be having at this point. Of course, it goes without saying, if there's there's some type of question that comes up during this course while I'm covering material, please don't hesitate to interrupt and ask your question. That's of importance, that you get your questions answered. Also, if you run into a question while you're working outside of this class time, of course, you can email me, you can come during an office hours visit, or you might even post a question in the class questions forum where your classmates might be able to respond to you fairly quickly. The most important thing is don't let your questions linger, because that only creates issues in the long run, okay? So you can see here from the overview, measurement 2 overview, the kinds of things that we'll be focusing on this week. And that's primarily how you convert from one unit system to another. And we'll be using the dimensional analysis process to do that. And also, we'll be, in the course of doing that, we'll be looking at, conversions within the metric system as well. And so I like to say that, by the time this is over, you should have firmly in your grasp a technique that will allow you to do unit conversions. Now, I always preface that by saying some of you have probably been doing this for quite some time, especially if you're like in the P-Tech program, or even if you were in high school and you had a science lab class of some sort and you had to deal with measurement. You might have learned the process for converting. I'm not here to tell you, you have to do it my way, right? No, what I always say to students is, if you are familiar with the process of doing unit conversions, you can use any technique that you are comfortable with as long as you show your work. That is of critical importance. This is not a class where I'm just looking at the answer that you get. This is a class where I'm looking at the process that you follow to get that answer. That is just as important as the answer. Having a correct answer doesn't always guarantee that you are following a correct process. So I look for your work to be completely filled in. Okay, I don't, and in fact, if you go look at the description for problem sets and discussions, it tells you, you must give complete work or a complete response. If it's a short, kind of short answer question where you don't have to solve anything. But all work must be shown at all times for everything you do for me, okay? So just to make sure everybody is following that, okay? So now let's take a look at the activities that you have to complete this week, okay? So you have a measurement 2 discussion that's due by Saturday, the 5th of February, okay? And remember, for all discussions, you have to post your response, and then you have to go back and respond to 2 of your classmates regarding what they posted. And we'll take a little bit deeper look at this on Thursday to make sure that the instructions are clear before you move forward. Your first problem set is also due this Saturday, And remember, problem sets lag a week behind. So the problem set number 1 actually deals with the nature of science and the SI-based properties and units, the metric, an introduction to the metric system and metric prefixes and so on, and then derived properties, because that's the material that we covered last week. Problem sets always lag a week behind, okay? So problem set number 1 is another opportunity for you to get under your belt once and for all the stuff that we covered last week, okay? And notice I put a link to the sample density problems that are under the useful links, because those can help you with the part C on problem set number 1 if you're looking for a little bit more practice before you complete problems that are part of the problem set number 1. But also recall last week I saw several problems that dealt with density, and you can go back and either watch the recording from last week, or you can even go under the announcements and look at the extra notes that are available to you regarding that topic, okay? All right. So let's take a look at the materials that I made available to you. So here is the first chapter that you'll tackle in the textbook, the CK12 textbook. Remember, I told you that I broke the textbook down by chapter. And so in this overview, you need to be reading and reviewing chapter 1 in the textbook. There's also videos available that you can watch that relate to unit conversions. And then, as always, the supplemental notes are what I'm going to use today. And then on Thursday, we're going to take some time and work some practice problems that deal with unit conversions, okay? Oh, sorry, let me scroll correctly. All right. So you see here the idea of a unit conversion. They pose a question here about, traveling in Europe, and of course in Europe they use different units than we do. They actually use the metric system in Spain. They give the example, or in Europe. And so if you're from this country and you're used to doing things like volume in gallons, then that whole idea of liters might not be, like something that could roll off the tip of your tongue, so to speak. But you would have to then go and do a conversion to get that equivalent value in liters. Okay. And so when you go through this process of converting, what you are doing is you are taking one measurement and converting it to an equivalent measurement. Okay. So you're not changing the value of your measurement, you're just expressing that measurement in a different unit. Okay. And of course, that's important if you're trying to communicate. So when you are going through the process of doing unit conversions, and on Thursday, we're going to get a little bit deeper in this. We'll do lots of examples on Thursday, but I want you to understand the process that we're going to be using. The process that I use to do unit conversions, and again, whatever your technique is, as long as you can show me, we're good. But the technique I use is, I call it dimensional analysis technique. And in that dimensional analysis technique, what you are doing is you're using a conversion factor to transform your measurement from one unit to another. Okay. And then the question becomes, well, what is this conversion factor and where do I find them? Okay. So you see an example of a conversion chart on the screen right now. And you're seeing what it does there, it gives you the equivalent in another unit. So for example, they have 4 quarts and the equivalent unit is 1 gallon. Or you see 100 centimeters and its equivalent is 1 meter, if you want to look at the metric system. And so if you're going to do unit conversions, you have to have access to some type of conversion chart or website where you can get conversion factors. And a conversion factor is nothing more than a fancy way of writing one. You know, when way back in your grade school life, you learn the idea that if you multiply or divide by 1, you don't change the value, right? And so if you're using a conversion factor and you multiply by it or divide by it, you're dividing or multiplying by 1, meaning you don't change the value, you just are transforming from one unit to another, or converting, I should say, from one unit to another, okay? Now, for my class, if you're working a problem on an exam, for example, and you need some type of conversion factor, it will be provided for you, or you will be able to utilize a conversion chart of some type to help you. So let me show you one tool that you have available at your disposal. If you look under useful links, one of the very first items is a unit conversion tool. And this unit conversion tool has, you know, conversion charts. So let's say, for example, you are converting weight and mass. You could come and use this as a, you could use this chart to get conversion factors. So for example, I have 1 kilogram and it tells me that that's equivalent to 10 hectograms. So now I know that if I have 1 kilogram, its equivalent is 10 hectograms. So if I multiply by the conversion factor 1 kilogram for every 10 hectograms, then I am not changing the value. I'm just going from kilograms to hectograms, for example, okay? And we're gonna solve problems doing that, you know, following that conversion process on Thursday. But what I want you to know today is, what is it that you're doing when you do a unit conversion, and you know, what tools you have at your disposal, okay? So bear with me for a second. When you have multiple screens open, it's got to navigate a little bit here. So there we go. All right. So they give us an example here of converting cups to gallons. Okay. So you have a gallon and you want to know how many cups that is. Okay. So notice that you do not have on this conversion chart that they provided, which is a nice conversion chart, but you don't have a conversion factor that goes directly from cups to gallons. That conversion factor is not provided. But what you do have is 2 cups equals a pint, 2 pints equal a quart, and 4 quarts equal a gallon. So you have to go through a multi-step process to get there. And that's what they're doing here. Okay. So you see 2 cups to 1 pint, 2 pints to 1 quart, 4, and they got a typo there. Yes, they do. It should be 4 quarts to a gallon. They made a typo on this page. I never noticed that before. I'm gonna have to write the publisher and tell them that, oh, no, can't do that. That, you know, they have a mistake there, okay? And so let's assume that this 4 pints is actually 4 quarts to a gallon. Then you would be canceling out the pints because those are like units in your, you know, in your math there. And then you would cancel out the quarts because that 4 right here should actually be quarts. Okay. And then what you're left with is the unit cups per gallon, right? So you see that when you multiply your top numbers there, 2 times 2 times 4, you get 16. And the units that is left after you do all the cancellation is cups per gallon. So you see that there are 16 cups in 1 gallon. And so this is what I like to call my dimensional analysis technique, because what you're in fact doing when you multiply by the conversion factor is multiplying by 1. So 2 pints per 1 quart is an example of a conversion factor right here in the middle. I don't know if you can see when I highlight things. Can you see when I highlight things? Anybody?
Yes, ma'am.
I didn't catch. Yes or no?
Yes, ma'am.
Okay, great. So you see, for example, I highlighted that 2 pints per 1 quart. That's an example of a conversion factor. And notice what they've done here is 2 pints divided by 1 quart. Those are equivalent, so it's actually 1. So what you're multiplying there is 1, because those are equivalent. Anything divided by itself is 1. 2 pints and 1 quart are equivalent, so you're dividing by 1. I mean, they make the ratio makes 1. And so you aren't changing the value, you're just changing the unit that is being expressed in. Sorry, everybody, my puppies want to have a barking fit this morning, I guess. All right, so that's what this whole week is about. You getting comfortable with this idea of doing unit conversions. Okay. And so you see there, it tells you, make sure to always cancel any units that are in the numerator and denominator of these fractions. These are like units that you cancel out. Okay. So let's look at another example. It says, how many feet are in 16 yards? So you have 16 yards and you want to convert that to feet. Okay. And so look at another way they're approaching this. And some of you might approach unit conversions this way. They're doing a ratio. Okay. So 3 feet is to 1 yard, as X feet is to 16 yards. Okay. So what they're saying is, hey, I'm using the conversion factor that's 3 feet in 1 yard. And then I'm going to use this equivalent ratios to figure out what number of feet will make 16 yards. So you see, then when you set it up like a ratio like that, you cross multiply. All right. So 3 feet times 16 yards equal 1 yard times some number of feet, X. Okay. And so then based on that, you got to, you go back to your equations business, you have to get X by itself. Okay. Now, some of you might be comfortable using this technique. Feel free to do that if that's how you like to solve things. Again, I stick to the dimensional analysis technique, like the example that we worked with the cups and the gallons. But of course, you are free to use this technique if it's something that you're comfortable with. A lot of times, this whole idea of setting up these ratios and solving an equation, some people might find challenging. And so on Thursday, I'll focus heavily on the dimensional analysis technique as a way to do the unit conversions that doesn't require you to do ratios. Okay. Okay. So let's see. I'm looking for a different example. I like this one, number 2, because this is one that shows a conversion that you use quite often in this course. Okay. So they want to know how many centimeters in a foot. Okay. And they're using a conversion factor 2.2 centimeters for every inch. Actually, We could be a little bit more precise than that. It's actually 2.54, but they round it to 2.2. Okay. So 2.2 centimeters per inch times 12 inches in a foot. Why did they do that? They multiplied by 12 inches in a foot because they wanted to cancel out the inches, right? Because the question is centimeters per foot, not inches per foot, right? They need to get rid of the inches. Remember, in this particular example, they don't have a conversion that goes directly from centimeters to feet, but in the conversion chart that's provided above, they do have a conversion factor 2.2 centimeters per inch. Okay. And so when you cancel out the inches and you multiply 2.2 times 12, you get 26.4 centimeters per foot. Okay. So they're using the dimensional analysis technique here. I like this technique because I can readily see what unit I'm keeping and what unit I'm canceling. Okay. All right. So again, to recap, when you are doing unit conversions, all you are doing is expressing the equivalent measurement in another unit. In order to do the conversion, you need a conversion factor. A conversion factor is a fancy way of writing 1 that allows you to convert from one unit to another. And if you multiply by the conversion factor, you can cancel out like units and then express the measurement in an equivalent unit. Okay. These conversion factors, which are fancy ways of writing 1, are found in conversion charts. You have an example of a conversion chart here in your book. I also showed you under useful links where you can find a conversion chart online. You are free to use either of them at any time you need to. Okay. If you're working on an exam and there's some type of conversion factor that you need, you will either be allowed to have access to a conversion chart or the conversion factor will be provided, because I'm sticking to my rule that I gave you last week, and that is no memorization in here. I don't need you memorizing things. I need you to use the tools that have been provided to you. Okay. So once you have the conversion factor, then you have to line it up properly so that you cancel out the unit that you have and keep the units that you want. Okay. And that technique is called the dimensional analysis technique. All right. And that dimensional analysis technique can be used to convert from metric units to English units, English units to metric units to metric units, or English units to English units. So in essence, the dimensional analysis technique will allow you to do any conversion because you have a conversion factor that allows you to express an equivalent measurement because you're multiplying by 1, which doesn't change the value. All right. So let me ask, what are your questions at this point?
I don't have any.
Thank you, Tiffany. I appreciate you letting me know that. Any
No questions.
no questions? Great, great, great. So here's what I need for you to do for me. Between now and Thursday, I want you to come back, review these notes, and I want you to make up an example problem dealing with unit conversion. Okay. Now, on Thursday, I'm going to pick from some of you your sample problem, and we're going to take a look at it. So you come up with an example problem that deals with unit conversion. I want you to work it out, and we're going to take a look at your problems on Thursday. Now, I might not get to everyone's problem, okay? but I'm gonna try to pick a select few and take a look at them. And then we're gonna look at some examples that, you know, I've already worked dealing with unit conversions. And so we'll have a good sampling of example problems. Those of you who I don't get pick on Thursday, you know, I mean, we have an hour and 15 minutes, so I may not be able to do everyone. You can email me your problem if I don't pick you on Thursday. And I'm going to include all of the example problems that we work, whether on video, whether it's one of mine or one of yours. I'm going to include all those example problems in the announcements that I post with the video from Thursday's class. Okay. So any questions about what you need to do for me between now and Thursday?
No, ma'am.
Okay, so come with your example problem worked out on unit conversions. We're going to take a look at some of them, and and I'll say this: don't be shy about if you make a mistake, because that I actually would like for somebody to make a mistake, so then we can have a learning moment to fix it, right? So don't be worried about that. Come with your example problems. Everybody will submit to me their example problems. Some of them will work out, and then we'll work some of my examples. Make sense?
Yes, ma'am.
Okay, well, I appreciate you joining in this morning. This is a topic where you got to do it. I could talk all day, but until we do it, until you do it, it won't be as clear as it can be. All right. So thanks everybody for joining in this morning. I'll get this video captioned and put out on in the announcements here, hopefully by tomorrow. And then I'll see you back here Thursday, bright and early, 10 o'clock with your examples. Y'all have a great day.
Thank you. You too.